We will continue. So this was a case for t less than -2. So when you observe figure number 1 and the modified form of figure number 2, it is understood that one is existing from 0 to infinity, the other one is existing from -infinity to 0. So there is no common duration where both the signal is coexisting. So we can tell that y of t is equal to 0 for this particular case. Case 1. Now, what will be your case 2? What will be your case 2? It should be a continuous case. As of now, you told t less than -2 case. Now, what should be your second case? 2 plus t should be greater than or equal to 0, because already we have done with the 2 plus t less than 0, right? So, next case will be 2 plus t greater than or equal to 0. So, t greater than or equal to -2. T greater than or equal to -2. This is the case that we are now focusing. So your 2 plus t greater than or equal to 0 means, of course, your figure 2 should be correct. Means this is greater than 0 as of now. Now you compare these two cases and tell me which is your common limit. Compare figure number 1 and 2 and let me know which is your common limit that is existing.
0 to 2 plus t.
Yes, it is 0 to 2 plus t. Any doubts? When you compare figure 1 and figure 2, it is understood that both the signals are existing from 0 to 2 plus t, which is a common duration. For figure 1, you don't have any signals in the negative axis. So we won't take any negative times into our consideration. So we'll start from 0 and we will end at 2 plus t. Why we are not going beyond 2 plus t? Because as you infer your figure 2, it is understood that the signal is not going beyond 2 plus t. It is abruptly coming towards 0. So we will be focusing a common duration starting from 0 and ending at 2 plus t. So your output equation will be like this: y of t is equal to integral 0 to 2 plus t x of tau into h of t minus tau d tau. Now from the given question, you need to write what is x of tau. Your x of tau was, what is your x of tau? Your x of tau was e raised to minus 2 tau, isn't it? Sorry. Yeah. Your x of tau was e raised to minus 2 tau u of tau and h of t minus tau. What is h of t? H of t was given question. You see the given question, h of t was u of t plus 2, right? So h of tau will be u of tau plus 2, but we need a h of t minus tau. So h of t was u of t plus 2. So h of t minus tau means simply you can put t minus tau instead of putting t. So it will be like this: u of t minus tau plus 2. Now these two things you need to substitute over here. So y of t will become integral 0 to 2 plus t. X of tau is e raised to minus 2 tau into u of tau, and h of t minus tau is u of t minus tau plus 2 into t tau. Nikhil Jha, you tell me what is your next step? Nikhil.
So we need to integrate.
Of course, we will be integrating, but before integration, what is these two terms?
So
One. Yeah, these are unit step signals or unit step functions. So its value will be 1 for t greater than 0. So I will assume this as 1 and then I will integrate it. So your equation now it will become y of t is equal to 0 to 2 plus t e to the power minus 2 tau d tau. So that will be, what is the integration result that you have? E raised to minus 2 tau divided by minus 2. Your upper limit is 2 plus t and lower limit is 0. And you can take minus 2 outside, so it will be minus 1 by 2 into e to the power minus 2 tau. Upper limit is 2 plus t, lower limit is 0. All of you simplify. So when you simplify upper limit, it will become minus 2 multiplied by 2 plus t, minus lower limit is e to the power 0. That is, take minus inside, take this minus inside, so this will be your 1. E to the power 0 is 1, isn't it? That 1 will become, that minus 1 will become 1. Minus, this minus is applicable to here, no? So it will be 1 minus e to the power of minus 2 into 2 plus t. This is your answer for which case? Which case is that? T greater than or equal to minus 2, isn't it? Which was that case? Yes, t greater than or equal to minus 2 case. So kindly refer that particular case or there. Then you will be writing your final equations in a. That is y of t is equal to, we have two different cases. One is for t less than minus 2 case and second one is t greater than or equal to minus 2. For t less than minus 2, it is understood that your output is 0 because there is no common limit or common signals to be taken in order to integrate. Whereas for t greater than or equal to minus 2, you had an output which is nothing but 1 by 2 multiplied by 1 minus e to the power minus 2 times of t minus, sorry, t plus 2, correct? E to the power minus 2 times of 2 plus t. So this is your final answer for y of t. So that is your convolution integrals. Take down any doubts, please ask. I will explain the procedure, whatever you need to do.
So-
Yeah, tell me. Ask.
So can we also define the magnitude?
Magnitude means? Whose
So
magnitude?
like in the like in the equation,
Yeah, in the
so like
equation.
while comparing both the graphs.
Yeah, that is, you are going to substitute the values and drawing the graph, right?
Yes, sir.
That you can do, but it doesn't carry any marks. Suppose if in the question they have specifically asked you to plot y of t, means what you will do? Specifically, you need to plot y of t. Then what you will do? Till minus 2, there is no signal. Till minus 2, you don't have any signal. But after minus 2, what you will do is, you will be substituting over here. Each and every values of t, you will be substituting over here and you will be finding the answers and plotting the graph. That's all. For example, if t is equal to minus 2, what is the answer? 1 by t, 1 by 2 into 1 minus e to the power minus 2 of 0 plus 2 is 2. So this answer is 1 by 2 into 1 minus e to the power minus 4. This you can calculate from the calculator. What is e raised to minus 4? Then 1 minus e raised to minus 4 whole divided by 2. That you need to plot over here. So like that, you can get many points for greater than minus 2 and then you will be plotting. That's all. Understood?
Sir, but we can express y of t as a function, no, sir, like multiplied with u of t.
But see, if you are multiplying with u of t, it should be having one condition. The condition is the signal should exist only for t greater than or equal to 0. But unfortunately, here the signal is not existing for greater than or equal to 0. Here it is existing for greater than or equal to minus 2. So you don't have that provision to multiply with u of t. Clear? If it is greater than or
Sir, u
equal
of t plus 2.
If it is greater than or equal to 0 means it is fine. Okay.
So, but can we multiply with u of t plus 2?
Yes, you can multiply with u of t plus 2. Very good. You can multiply with that because u of t plus 2 is nothing but from minus 2 to infinity.
Okay.
That you can do. Very good. Very good. So that and all, it is optional. That is what I was saying. If you are enough confident in writing in that way means you can do, but please don't take any mistakes or please don't make any mistakes. Okay. You otherwise you can stop over here. If you are really confident in plotting the graphs as well as plotting, I mean writing it in a form of equation means you can proceed. Otherwise you can stop over here. That's all. So as Sayan said, you can write y of t in terms of u of t plus 2. So your answer will be 1 by 2 into 1 to the 1 minus e to the power minus 2 of t plus 2 into u of t plus 2. Why you have multiplied with the function u of t plus 2? Because it's a unit step function which will be existing only from minus 2 to infinity, isn't it? This is u of t plus 2. And our case is also defined from minus 2 to infinity. That is why while writing it in a form of single equation, you can multiply that term with a corresponding unit step function. So that unit step function is nothing but u of t plus 2. Why you have not gone for u of t? Because u of t is something which is existing from 0 to infinity and u of t plus 2 is something which is existing from minus 2 to infinity. I hope it is clear for you. Any doubts other than this? Okay, next topic. So as of now, our problems are over. Now we need to discuss few properties of LTI systems. Okay, just a property statement and few derivations. Not so big. It is very easy to understand. So I will dictate that thing. Okay, take down the notes. Properties of impulse response. Properties of impulse response. Representation for LTI systems. LTI systems means as of now we have discussed what is impulse response. That is nothing but your h of t or h of n. If it is discrete time system, it is h of n. If it is continuous time system, it is h of t. So impulse response is nothing but if you take one system and if you give an impulse input to that system. What is impulse input? It is del of t. So after giving del of t, you will get an output, right? That output is nothing but your h of t. If you are taking a discrete time system, you will be providing del of n. Correspondingly, you will be evaluating its output. That is nothing but your h of n. This is called as impulse response of a continuous time system, and second one is called as impulse response of a discrete time system. After knowing these two expressions, either h of t or h of n, you can compute y of t for a given value of x of t. So x of t, it will be given to your system as your input. H of t you can get like this way, that is giving del of t and taking h of t. So once you know x of t and h of t, you can have the desired output of a system by performing convolution integral or convolution sum depending upon the nature of the system. That is what we have done as of now. Okay, how you will find h of t? By giving del of t, you can have the output, that is h of t. Now h of t you will take, x of t you will take. Okay, and you will perform convolution integral or convolution sum, and from that you can find the expression for output signal y of t for different time duration cases. Now here we will be discussing about the properties of these impulse response for LTI system. Means based upon h of t, how you can characterize a system. Those properties we are going to discuss. So all of you write the first property, commutative property. First property is commutative property. The convolution operation in both continuous time and discrete time are the convolution operation in both continuous time and discrete time are commutative. The convolution operation in both continuous time and discrete time are commutative. That is, x of n star h of n is equal to h of n star x of n, and x of t star h of t is same as that of h of t star of t. Okay, this is your commutative property. Means if you interchange the position of h of n or x of n, your output will be still same. After performing the convolution in either way, output y of n will be same. That is what this meaning is. Understood? Second property, distributive property. Distributive property. That is, for discrete time domain, x of n convolution h1 of n plus h2 of n is equal to x1 of n convolution, sorry, x of n convolution h1 of n plus x2 of n convolution h2 of n. Sorry, x of n convolution h2 of n. Of n convolution h2 of n. This means that you are having only one input but two impulse response. Okay. I'll show you in a block diagram representation. You are having x of n as your input. This x of n is going through a system whose impulse response is h1 of n. Similarly, parallelly, it is going towards another system having an impulse response h2 of n. Then if you add this, what will happen? You will get an output which is nothing but x of n into h1 of n plus, sorry, x of n convolution h1 of n plus x of n convolution h2 of n. This is called as distributive property. This is your y of n. Similarly, you can write it in continuous time domain also just by replacing n with the t. Take down. Similarly, it will go for continuous time case also. That is x of t convol h1 of t plus h2 of t is equal to x of t convol h1 of t plus x of t convol h2 of t. So this is the distributive property of an impulse response in continuous time domain as well as in discrete time domain. So please keep it in mind that whenever you have a system characterized by an impulse response h of t, and when you know its input x of t, by using convolution process, you will be getting your output y of t. So what is the application of convolution? Just find the output for any arbitrary input, provided you must know its impulse response characterization. Then for any input combination, you can take its output by performing this mathematical operation. So I will stop here and we will continue in the Monday's class. So again, I need to discuss 3 to 4 properties, and then I will be winding up the second module and I will be starting the third module on Monday. Don't miss the class, attend regularly. Otherwise, you will lose continuity in between and it will be very difficult for you. Hope you are able to track those who are attentive, those who are regularly attending the class. It is very easy subject, okay? But those who are missing the class in between, they will feel very difficult in the semester and examination. All the best. Thank you.